Good day and welcome to the Math Salon. I'm Dr. Animendem. Today we'll be looking at some advanced level questions, two of them, and this concerns trigonometry. So the first question says, show that the tangent of pi on 4 plus theta plus 1 is equal to 2 divided by 1 minus tan theta. In questions that require you to show that, it's important that you always look at them. I would advise that if you look at the left hand side, look at the right hand side, and the left hand side looks more complicated, sometimes it's easier to simplify that. But it will always depend. This is not a rule that works always, but it's good to think about it. Sometimes you may require to simplify your right hand side to show it's equal to right hand side, left hand side, or simplify the left hand side to show it's identical to right hand side, or you do both at the same time. Whatever the case, it's important to pay attention. The side that is usually complicated can usually be simplified compared to expanding into more complex terms. So to do this, for example, I would like to maybe take you back a little. I will divide my board into two and we say, I see this as tangent of two angles here. So this is like the tangent of A plus the tangent plus B. Usually I don't remember the identity. Sincerely, I don't remember the identity of tan A plus B. I have some ideas, but I'm not sure it's exact. So to avoid making mistakes, it's good to go through some other simple things that I know. For example, I know that this is the sine of A plus B divided by the cos of A plus B. Why? Because the tangent is equal to the sine over the cosine. So the tangent of theta is equal to the sine of theta divided by the cosine of theta. That's something simple that we've learned from long time ago. So the next thing is, I also remember the identity for sine A plus B. And that is, you remember sine always likes to go along with cos, but cos doesn't. So for the sine of A plus B, this is going to be sine A, sine B, cos B, it likes cos so much, plus cos A, sine B. So the sine of A multiplied by the cos of B, plus the cos of A multiplied by the sine of B. That's what I have here. Divided by, the cosine always sticks by itself, it leaves signs alone. So this is cosine of A, cosine of B, and it's weird, it changes the plus to minus. The sine of A, the sine of B. This is something that you would remember. If not, at least this is a reminder. But my problem is I would like to get something in terms of tangent, because the right hand side has tangent, it has nothing with cos. So what do? I still remember, if I divide cosine by sine by cosine, then I get something in terms of tangent. For example here, if I divide this by cos B, for example, and cos A, then the cos A and the sine A can be together, the cos B can disappear. So, but then I get something in tangent, and I also get something in tangent here. Here it becomes 1, and I get something in tangent. So let me try that. So I would divide my numerator by cosine A, cosine B, and divide the denominator also by cosine A, cosine B. So if I do that, then I have something like sine A, cosine B, plus cosine A, sine B, divided by cosine A, cosine B, all that. The denominator now, cosine A, cosine B, minus sine A, sine B, all that divided by cosine A, cosine B. So this is beautiful. Mathematically, that is fine. You can do anything in a mathematics salon as long as it is legit. It's okay. It's correct. So if I do that here, then I see I can split my divisor. If I have 1 plus 2 divided by 3, it's the same like 1 over 3 plus 2 over 3. So if I do that, this is that on that. If I divide this by this, then this cos B goes away with this cos B. Sine A, cosine A remains, and that is tan A here. Plus, if I divide this by this, the cos A disappears with the cos A, and I get sine B divided by cos B, and that is tan B. Divided by, if I divide this by this, then I get 1. Cos A disappears, so I get 1 here. Minus, if I divide this by that, I get sine A over cos A, sine B over cos B, so that is tangent A, tangent B. So it means I have an expression that I can use now on this side of my equation. So let's go back to the equation now. The equation was the tangent of pi on 4 plus theta. I will use this now. My A here is pi on 4. B is theta. See that from here. So A is pi on 4, B is theta. So I'll just do that. So I will look at this and I will substitute there. So this is tangent of pi on 4 plus the tangent of theta divided by 1 minus the tangent of pi on 4 tangent of theta. If you arrange this well, you will see that this is simply 1 plus tangent of pi on 4, that is 45 degrees. The tangent of 45 degrees is 1. So 1 plus the tangent of theta divided by 1 minus, this is also 1 here, the tangent of theta. So my left hand side was actually the tangent of pi on 4 plus theta plus 1. So I take this here, I put plus 1. So this is 1 plus the tangent of theta all over 1 minus the tangent of theta plus 1. This is also can be written as 1 over 1, and I can look for the lowest common multiple for the two of them, and that is 1 minus tangent of theta. 1 minus tangent of theta divided by 1 minus tangent of theta is 1. 1 times that is 1 plus the tangent of theta plus 1 minus tangent of theta divided by 1 is 1 minus tangent of theta times 1 is 1 minus tangent of theta. You see that this goes off and I'm left here with 2 divided by 1 minus tangent of theta. For the second part, it says, show that the 2 cosine of 2 theta sine theta plus 9 sine theta plus 3 is identical to 3 plus 11 sine theta minus 4 sine cube theta. If I look at my left hand side, I see that there's a cos term here. If I look at the right hand side, there's no cosine term here. So I think one of the key things to do is, how do I do away with a cosine and bring something in terms of sine? We will try to use one of the things you already indicated here. So I will look at this cosine 2 theta. So my cosine 2 theta can be written as cosine of theta plus theta. That's nice, yes? And if we look well, I already indicated that the cosine of A plus B is a cosine of A, cosine of B minus sine of A, sine of B. So if we look at this well, this is going to be the cosine of theta times the cosine of theta minus, you see, it was minus there, the sine of theta times the sine of theta. This is twice, so this is a square. Minus sine that. I have cos here, but I don't want it because, yeah, my right hand side has only in terms of sine. So from the baby identity we know before, cos square theta, there's a standard one for trigonometry, sine square theta is equal to 1. So if I take sine to this side, it means cos square theta is equal to 1 minus sine square theta. So I can replace this with that. If I do that, I get a 1 minus sine square theta minus sine square theta. And that is 1 minus 2 sine square theta. So I can come to this my expression here, and I say, so my 2 cosine of 2 theta sine theta plus 9 sine theta plus 3 is equal to 2 times, I put this that we had here, 1 minus 2 sine square theta times sine theta. So this part here is replaced. This is my 2 here, this part is replaced, and the sine theta is there, plus 9 sine theta plus 3. I can open this now. 2 times 1 is 2, minus 2 times that is 4 sine square theta. We still have sine theta outside, plus 9 sine theta plus 3. I can now open this up. This becomes 2 sine theta, this time that, and this time that is minus 4 sine cube theta. Then I continue with my terms, plus 9 sine theta plus 3. This 9 sine theta and 2 sine theta is 11 sine theta. So 11 sine theta minus 4 sine cube theta plus 3. And that is the right hand side that we have here. Thank you. I hope you liked it. If you did, please give us some thumbs up, subscribe, and most especially share with your friends. Please share. We need this, especially at this time. Thank you.